Hi, welcome. Today we're going to learn about substituted hydrocarbons and their reactions. You may know that carbon follows us everywhere in our daily life. We can find carbon in the atmosphere, in the air, underground, basically everywhere. Carbon and hydrogen help form these polymers that have many purposes. Paired together with other elements, they make such a strong bond that you can see, for example, in bulletproof vests, that they become so strong and they are so tightly holding together that it is, well, practically impossible to break them. Or also in another example, you can see when you're ironing a shirt that doesn't need to be ironed. The molecules of the elements that shirt contains are so strongly together that they are almost impossible to break down. There can be many examples of what I just told you. An example can be a functional group of polymers. This group, it could be one atom or a group of atoms that will always react in a certain way. The simplest functional groups can be found with the halogens, which are the elements that are located in the periodic table in the column 7A. These halogens are fluorine, chlorine, bromine, iodine, and acetylene. Any organic compound that contains a halogen can be called a halocarbon. If you replace any of the hydrogen atoms with a halogen in an alkyne solution, you will create an alkyl halide. By definition, an alkyl halide is an organic compound containing a halogen atom covalently bonded to an aliphatic carbon atom. This is what I explained to you earlier, that the hydrogen atom has been replaced by a halogen, which are the elements in the column 7A, and it's now covalently bonded with a carbon atom. Instead of being the hydrogen, which I said earlier that it would make a really strong bond, now an alkyl halide will be formed with a halogen element. So you may wonder where all these organic compounds come from. Most of the organic compounds can be found in petroleum. But what is petroleum? If you are a driver, you may know that your car needs gasoline, and gasoline comes from petroleum. Petroleum is a non-renewable resource because it takes such a long time to create that it is considered non-renewable. Petroleum can be harmful to the environment, but at the same time has many benefits to the human being because it can help them stay warm, it can help them have gasoline to move. It has its ups and downs. Petroleum is basically hydrocarbons, but it is specifically alkanes. You may wonder how alkanes can be converted in a different way that it doesn't form an alkyl halide, alcohol, and amides. Well, there are many different ways, and let me show you all of them. The first one is a substituted reaction. Think about it this way. A substituted reaction is when you have two atoms or two groups of atoms and you replace one of the atoms or the group of atoms with another atom or group of atoms. It will have the same function, but it will be different types of atoms. Example, with alkanes, like I said before, hydrogen atoms can be easily replaced with halogen. More specifically, chromine and bromine, and these can form halogenation. Most of the organic compounds has oxygen bonded with carbon atoms. Since oxygen has six valence electron, it commonly takes two covalent bonds to form a stable octet. An oxygen bond can form a double bond with a carbon atom replacing the hydrogen atoms, or it can make it with another element and then another element. An oxygen-hydrogen group covalently bonded to a carbon atom, it's called a hydroxyl group. And then in an organic compound where a hydroxyl replaces a hydrogen atom of hydrocarbon, it's called alcohol. Trust me, I know that learning all of this theory can be sometimes hard and sometimes easy. In my case, it's mostly difficult all of the time. But with practice and reading, you'll get it. Another example are ethers. An ether is an organic compound containing oxygen and 2 carbon atoms. In here, you can see an example of an ether. You can see methanol and methyl ether. Then we have amines. Amines contain nitrogen atoms bonded to carbon atoms in an aliphatic chains or aromatic rings and have the general formula RNH2 negative. You can see in here the formula if you didn't quite understand it. So basically we have all of these different types of compounds which are mostly of hydrogen, and then we have halogens, and then we have carbons. Well, to know if you're doing it right, you have always you have the carbon atoms and the carbon bonds, because carbon is what makes it such strongly to be together. Now we have organic compounds containing carbonyl groups. The arrangement in which an oxygen atom is doubly bonded with a carbon atom, it's called a carbonyl group, which I said earlier we're going to go into it. This group can be represented as shown below. This is the function group in organic compounds known as aldehydes and ketones. So here you can see O for oxygen, C for carbon, or C for carbon, O for oxygen. These are the different types of mix-up where you can find the oxygen and the carbon doubly bonded together. So as I said, we had aldehydes and ketones. An aldehyde, it's an organic compound in which you can find the carbonyl group at the end of the sequence. You remember before I showed you oxygen carbon and carbon oxygen. So aldehydes are oxygen carbon. And now we have ketones as opposed to aldehydes. The ketones, in the bond you can find the carbon in the carbonyl groups bonded together with 2 other carbon atoms. So here, as in this diagram, you can see oxygen, carbon, 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 or oxygen, carbon, R, which also represents the carbon because it's in the general formula. So thank you for watching. We have come to an end. It has truly been a joy showing you the substituted hydrocarbons and their reactions. I hope you took something from this video and hope to see you next time. Bye. Thank you for watching. Bye.